In this video, what we're going to be doing is looking at terminating and recurring decimals. So what do those mean? Some of you may have heard of this sort of these terms before in primary school or earlier in your schooling life. Well, if we start with the word terminating, you can think of Arnold Schwarzenegger as the Terminator, and he was destroying people, as ending people. So terminating means that the decimal places end. So decimal places end. And recurring decimals means that the decimal places keep going. Places keep going. So recurring means it goes on and on and on and on and on. Much like how I might sound. So, for example, we want to see an example of a terminating decimal. So a terminating decimal has, if you want to use the proper terminology here, has a finite number of decimal places. So finite just means it ends. We don't have to round up or round down, it just ends. So, if we want to convert 3/8 into a decimal, so what we're going to do is we'll get our old division here. You can use either long division or short division. For this kind of fraction, I'm going to use short division. So I'm going to do 8, and I'm going to put a 3 there. Now, 8 can't go into 3, as we probably are quite aware, so I'm going to put a big old 0 at the top. Then I'm going to put some decimal points on either side. I'm going to chuck a few zeros here just to have some up my sleeve. And then I'm going to go and see if 8 can go into 30. And 8 goes into 30. This would be 3 times. And then we've got 6 remaining. So we're going to find 8 goes into 60. Let's think about how many times 8 can go into 60. So 8 can go into 60. What it would be? Well, let's go and it would be 7 times, because 7 times 8 would be 56. So, and that would be 4 left over. And 8 goes into 40 5 times. So there we go. And is there anything left over? Well, no, there's nothing left over because it goes exactly in. So therefore, it's a terminating decimal. So it's 0.375. A recurring decimal has an infinite number of decimal places. And usually that repeats. So a recurring decimal is one that has an infinite number of decimal places and they repeat. If then don't repeat, we can't necessarily say that it's a recurring decimal. That will be a form of irrational number, which we'll talk about at some other stage. So negative a third. So if we want to go and describe this, so I'm going to do the same thing. I'm going to leave the negative till last. We'll just deal with it as if it was a third. So 3 can't go into 1, so that's going to be a 0 there. Find out how many times 3 can go into 10. 3 can go into 10 3 times, and 1 left over. 3 goes into 10 3 times, and 1 left over, and 3, and so on and so forth. So to be able to describe it as a recurring decimal, what I'm going to do is I'm going to go 0.3, and I'm going to put a little dot up there. You might also see it written in this way. You might see it written like this, with the little bar up at the top. That is okay. If you prefer to write it in that way, that is fine. Usually we put a dot for one digit and then a line or bar for multiple digits. So we'll see in this example here. So when we're doing to check if something's recurring, we have to keep going until we absolutely are sure that it is recurring and it's going to go and repeat itself. So for example, 2 7ths, as a spoiler alert, anything with a denominator of 7 looks suspiciously like it won't repeat. So let's go and have a look at this business. So I'm going to set up quite a lot of decimal places for this one. So we've got 7 can't go into 2. 7, let's see, 7 goes into 20 twice and 6 remainder. Okay, 7 goes into 68 times and 4 remainder. 7 goes into 45 times and 5 remainder. 7 goes into 57 times and 1 remainder. 7 goes into 10 once and 3 remainder. 7 goes into 30 4 times and 2 remainder. 7 goes into 20 sorry, I just had a brain fart there. 2 goes in twice, and 6 remainder. And then if 7 goes into 60, that would be going in 8 times, and 4 remainder. And then 7 goes into 45 times. And now we've seen the pattern go. We are definitely absolutely sure that the pattern's going back. I tend to make it about 3 digits to see if it will repeat. Usually in most examples that will be fine. And obviously in a test scenario, if you weren't allowed to use your calculator, then that's fine. We wouldn't make anything terribly complicated. Otherwise, you can always check on your calculator. So because it repeats at the 2 there, what I'm going to do is I'm going to write this as 285714, and then put that line over at the top there. So that just means that it's repeating for those digits over and over again. So a vulgar fraction is a fraction that's been converted from a recurring decimal back into its original fraction. It's a bit beyond our current standard that we need to do, but for those clever clogs, you might be able to give this a go. So we've got here this one example of 0.232, all recurring. So for this one here, I'm going to show you the quick way and then the understanding way of how it goes about. So essentially all we need to do is you see how many digits there are, 232. And divided by the number of places there are, but instead of putting zeros in the thing, we put 9s. So it becomes 9, 9, 9. And then check to see if anything can be cancelled in there. So 232 divided by 999. No, nothing can be cancelled in there. So just as so that would be the answer. That would literally be that. And if you pop that, if you like, pop that into the calculator, so 232 divided by 999, you'll see that it's going to get there 232, 232, 232, 232. If you, as another, let's say we had 0.11 all recurring, so this would be simplified to 11 over 99. And then what we can see is can that be simplified? Well, yes, because 11 and 99 are both divisible by 11. So we'll divide that by 11, divide that by 11. And then what we do is we can simplify that, and that would become 1 over 11th. Sorry, not 1 over 11, silly me. That would be 1 over 9. So we've got 1 divided by 9, and then we get 0.11111. So here's the logic behind it. And what I might do is I might just erase this example, and I'll just say, how did we get 0.11? So this understanding is very well above year 8. So if you can get the fact that you would just take the digits and put them over 9s, then that's step 1, and that's fine, and that's a really great and easy way to convert backwards. If you would like to know how we actually work this out, this would be even considered to be year 11 specialist level, but here we go. So imagine that 0.11 recurring is the same as saying 0.111111 on and on like that. Now what I'm going to do is I'm going to go and just label that as some variable, x, and that is 0.111111 on and on. And what I'm going to do is I'm going to times both sides by 10. So you might be wondering why on earth I'm doing that. So I've got 10x is equal to 1.111111. So why have I done that? Well, if I know that 10x is equal to 1.111111 on and on like that, and I know that x is equal to 0.111111 like that, well, I can get rid of the recurring decimal places by just doing a big old minus, like so. Whoop. And I get 9x is equal to 1.111 on and on. Take away 0.1111 over again. Makes that 1, because all the decimal places all cancel out. Then we divide both sides by 9. We get x is equal to 1/9. So that's how we got that particular result. So that's the mechanics of it, and on the left is just a nice, quick and easy way to be able to show how you can convert a recurring decimal back into its original fraction. As a last point, you might see on there the fact that it says this comment about an exact answer. If asked for an exact answer, that means the answer should not be rounded up or should not be a rounded up decimal. It should either be a fraction or square root. So if you're ever asked for an exact answer, that's what it means. So I know some people might prefer to, instead of saying, 1/3, they might prefer to write 0.3 and as rounding up. Exact answers means we have to have them exact. Generally, we prefer the fraction rather than recurring decimals because sometimes putting a little bar or a dot can be easily missed, whereas a fraction is definitely the answer. You can't miss that it's a fraction. So I would recommend just keeping things in fractions or square root form, which we'll also talk about a little bit later when we cover indices.